College of Aeronautics.
If you would like to go, feel free to.
I don't even know what aeronautics is.
I think it's like
Pilot. Aerodynamics? I didn't even see that.
aeronautics. It's like
Well,
I think it's like flying
flight.
planes in the ocean.
Aeronautics would be flight. Anyway,
Like a water plane.
so while that starts to react, we're going to do the reaction equation up here. So iron metal, of course, is simple, Fe. And the metal part, we're going to note with a S for solid. Reacts with copper-II nitrate solution. I suppose I'll stick with the red color for that. But copper-II nitrate, copper, Cu, the 2 tells us it has a 2+ charge. Nitrate, NO3, it has a 1- charge. And so 2+ here, 1- here, crisscross them, and we end up with Cu1 NO3 2. So Cu1 NO3 2, AQ. And I'm going to move those two a little bit closer and move all of that a little bit to the left. So these are our reactants. AQ for aqueous, for dissolved. Yes, the aqueous means that it's dissolved. That is going to give us, it turns out, because it's a single replacement reaction, one thing is replacing another thing. Iron, of course, is a metal. So what's the metal part of the copper-II nitrate? The copper. So the iron is going to replace the copper, and the copper is going to come out of solution. And so what we'll end up with, as this reaction continues, is solid copper metal and iron nitrate solution. It should be iron 2 as well. So FeNO3 2. Aqueous. There is a small possibility that it'll instead form iron 3 solution. If it forms iron 3, 3+ charge, nitrate 1- charge, crisscross, you end up with an iron 1 NO3 3. So the other possibility is that it could potentially form FeNO3 3 aqueous. And there's even a possibility it could form a mixture of these two. Anyway, one thing that we haven't recovered yet this year, but we had way back in the past, is that reaction should be balanced. So up here, there's 1 iron, 1 copper, 1 copper, 2 nitrates, 2 nitrates. It's the first one today that I don't actually have to have balanced because it's already balanced. However, if it forms this one, there's 3 nitrates here and 2 nitrates here, so we end up having to put a 3 there and a 2 there. That makes our nitrates balanced, but now our coppers are off, so we end up having to have a 3 there. Our coppers are balanced, but our irons are off, so we'd have to have a 2 there. So one of these two is the actual formula. I believe it's probably the first one, but I don't know for certain. We can do the test once it's done to figure out whether it's on iron 2 or iron 3, but we're not gonna. Anyway, what that means over here in solution is that we should begin to see copper metal on the paper clips. And if you look at the paper clips, and they're not necessarily the easiest to see from where you are, they are no longer a shiny silvery metal. They look very dark or black, and if we were to pull that out, you would be able to see the reddish coating of copper metal on it. As we let it continue to go, the coating of copper will get bigger and bigger and bigger. These two, which have been going since first period and last period, this one here, this was silver nitrate solution with copper metal in it. And so if you look at its reaction equation, when those two replace one another, silver comes out and we end up forming a copper nitrate solution. This solution was clear to start with, but notice now it's turning the blue color. We're making this stuff with this reaction. And the shiny stuff that you see on the surface there, that's silver. and it was a fairly thin coating early this morning. You can see it's getting fairly thick and beginning to rain off of the copper metal itself. It's beginning to fall off the copper metal, but that is silver metal dangling off the copper wire, and every time it sags down like it has right here, it starts to reform on the wire, and so we're still getting the reaction going on here, but the silver coating actually covers the wire and slows the reaction rate down quite significantly. This one here was the same clear solution that this started out with, but this time we have iron metal reacting with silver. The silver is not quite as thick or obvious here, one, because it's only been going for a period, and two, because this reaction is a little bit slower. I think it's also because I'm using steel instead of true iron. I'm using paper clips for my iron wire. I thought I had a spool of iron wire, but it turns out it wasn't. It was... it's something else. I don't know what it is yet, but it's not iron. Anyway, here you can definitely begin to see a coppery color. The other thing is, just like this solution here changed color and went from clear to blue, this one here should do the opposite. It should go from blue towards a different color. Not necessarily clear. Iron solutions, depending on whether you have 2 or 3, will be either clear or yellowish. Yellowish, rustish looking color. So we'll have to check on it on Monday and see what it actually did, but I'll let these run over the weekend. The video, I probably will only go about 15-20 minutes. I might go a little bit longer with as slow as this one's going. It's going decently slow compared to the other two. But I'll have the videos of all 3 of them posted in Classroom later on, hopefully today. Feel free to take a look. I encourage you to take a look, compare and contrast the 3 different reactions. Again, you're only accountable for recording observations of this one. And here in a few minutes, as the period ends, if you want to come by and take a look at it, just be careful not to bump the setup. Feel free to do so and take a look at the copper coating there on the iron wire. As I said, over time it will get thicker and thicker and thicker. And hopefully we'll be able to see more evidence of that on Monday. Questions? That's it for the demo. Like I said, be sure you walk by it as you head out at the end of the period, and be sure that you study for the test on Monday. As a side note, for if you are curious, this morning I've been following the Rosetta mission quite closely. The Rosetta mission ended today officially. Back in 2004, European Space Agency launched a spacecraft to go towards a satellite. To save on building cost, fuel cost, and weight of the vehicle, they planned a intentionally long and complicated orbital path to get it to the comet. It took 10 years, a decade to get to the comet, and spent most of that decade in hibernation, and they weren't totally sure they'd be able to wake it up out of hibernation properly. But it did wake up in... I would say it was January of 2014. It got closer and closer to the comet all summer. By the end of the summer, it was orbiting the comet. It's the first time we've ever orbited a comet. We've done flybys, we've done follows, we've done crash lands on the comet, but comets are small and don't have a lot of gravity. It's very hard to get them to hold your spacecraft in orbit. But they managed to do that with Rosetta here in November of 2014, and those of you that were freshmen then may remember we followed Philae's landing. Philae landed on the surface. It actually bounced on the surface and didn't land properly, and it bounced a couple times. Instead of landing where it was supposed to and getting 12 hours of sunlight a day, it landed in kind of a shadowy crater and was getting an hour and a half of sunlight a day. Instead of its solar panels recharging its batteries, we saw its batteries just start to plummet immediately. We also knew for certain that the harpoons hadn't fired. There's debate about why, and we don't know for sure why they didn't work. But the lander, instead of having the harpoon fire and grab onto the comet's surface, instead bounced on the surface and bounced into kind of a bad hole. And it actually bounced, and the bounce took like an hour and a half, 2 hours, the first bounce, and then it had 2 more bounces before it came to a final landing. Anyway, they hurried up and did all the science they wanted to do. They planned on it taking a week. They changed the order of things and smushed together the schedule and got all of the science they wanted out of it in about 3 days as they just watched the battery levels continue to plummet. A week later, Philae went to sleep and went into hibernation mode, and they assumed that they had lost it. Never did figure out where it had landed at the time. The comet, meanwhile, was coming closer to the sun. It begins to grow its beautiful tail. Rosetta's following it and orbiting it and taking pictures the whole time. And right as it was at closest approach to the sun, Philae all of a sudden woke up. And so in the summer of 2015, we got about a month worth of communications from Philae, but they're very spotty. We couldn't always lock onto the signal. And before they were able to figure out exactly where Philae had landed, we lost the signal again. It had went into shadow again, and they couldn't hear from it. Rosetta continued to go around the comet. The comet continued to go around the sun and then on out of our solar system. And as it goes far enough out, being solar powered, it's just doesn't have enough sunlight to keep going. So the normal way we end a mission is to intentionally crash land it onto a surface. They started that maneuver about a month ago, and about that same time, by coincidence, in scouring the photos, they finally found Philae in the photos. And so back about Labor Day weekend, the exciting news was we actually figured out where Philae landed. And as one of the scientists put it, we had a lot of data about ground zero, or the landing site, but we had no clue where the heck ground zero, the landing site, actually was. Now we know where it is, and we can put the data in context. Rosetta had already begun its deorbit maneuver, and so it wasn't going to be able to take more photos of Philae, which we would have liked to have been able to do, but it was deorbiting, and they had already picked out a crash site, and today was D-Day. Yesterday they started the final burn to push it towards the comet, and for about 24 hours it was just going in towards its imminent doom and demise. This morning, I knew the window. I was following it last night. I was following it again this morning, and I was hoping I'd make it to school in time to see the final signal and be able to follow it live. I got in here, and by the time I got logged into the computer, it had crashed about 5 minutes beforehand. But we went from getting a signal from the spacecraft to getting no signal from the spacecraft, and that told us then that the mission was over. This is the last photo that it took, we think, which is 51 meters above the surface. It's at least the last photo they released, but it crash landed into the surface, and its mission has come to an end. It got us a lot of data, and this lady right here works as a journalist for the Planetary Society and just does an amazing job of following space missions. So I've been following her tweets quite a bit today, but she commented specifically that we have it's one less outer solar system spacecraft we have, and within 2.5 years we'll have none out there doing active science, which it really hadn't sunk in with me that was the case, but we have no missions en route to a thing beyond the asteroid belt, and all the missions that are operating out beyond the asteroid belt will be finished in 2.5 years. And it'll be the first time in my life that we've ever not had an active mission in the outer solar system, which is kind of sad. But I'll take it if it leads to a true push to Mars. If you didn't hear Elon Musk's announcement earlier this week, I think it's ambitious, but it should be exciting. Anyway, be sure you take a look at this as you head out today. And if you want to learn more, words out of her,
I saw that on Snapchat.
yeah.
How many people listening?
He would like, his goal is before the century is out, initially it will be batches of 10s at a time, but he wants to actually colonize, maybe it was 100,000. I think he's like big on Mars. Having on Mars, and he's factoring in people going there and coming back. And so he's even factoring in not everyone staying there. Yes, just push it in. And so,
You've seen the movie Doom, haven't you? You ever seen? Yeah, like the video game Doom, the movie.
Dude, I did not see the movie. Was it? Was it Mars? I didn't.
It was Mars.
I didn't realize
It kind of sucks in the movie, but
yeah.
it's the thing. The science in it is cool.
He's putting a lot of money into this.
He has.
And Jeff Bezos, too.
Yeah, and he's so much more secretive. I mean, I want to root for him, but he does not release information publicly, and so
Bezos?
Bezos just does not, and it's frustrating. I mean, when they do something big, he says, "Oh, hey, we just did something big," but he doesn't say, "Hey, we're about to try something that could be big." You know, Elon Musk, on the other hand, with SpaceX, they started trying to do this land the booster upright thing, and in Earth it worked fine. The first time they sent a thing into space and then tried to land the rocket again, it missed and it fell over and it blew up. And then the next time they tried landing on a barge. They haven't successfully landed on land yet, but they tried landing on a barge. It falls over and blows up. But now they've done it I think a half dozen times, and it's just like a couple failures, and they're big spectacular failures, and unfortunately very public failures. But he's like, hey, we're gonna try this. It works or it doesn't, and yay or nay. Oh well. But then with Bezos, it's more of, hey, we just did this. Here's the videos of what we just did, and we don't get to see the failures, and we don't get to have the excitement leading up to the event. Like and so I want to root for him too, but he's just so private about it.
Yeah.
But oh well. But no, I'm excited, and I'm all for taking out the hands of governments and letting companies try it instead. Yep. I'm all for it. Anyway, have a good day and a good weekend. This is fascinating to me, the amount of pieces that are falling off but then floating. I presume we're getting a gas trapped on the surface. I don't know whether that's... I mean, it's possible we're... I don't know. It's possible there's just air bubbles trapped in there and they're being released now. The other possibility would have to be some kind of acid reaction, reacting with the metals and pulling them off. Can't imagine the light's enough to do heat and convection currents. I suppose it could be. Down at the bottom there seems to be discoloration. And I think I'm beginning to notice that it's turning a yellowy color, or at least a green color because of the presence of some yellow.